Right. Okay. Good evening, everybody. My name's David. I'm one of the operations managers at Naturetrek. I was going to speak last this evening, but yes, I'm happy to go in first with a little talk about the Northern Lights. These are fantastic things that people hope to see when they visit the polar regions. We're talking about the polar regions this evening, so I thought it was a suitable thing to maybe give a little bit of a talk about, a little bit about the science. And which tours we might be able to see Northern Lights on. Not so much the tours that both Paul and Tim are going to talk about, because Northern Lights really cannot need for the skies to be dark. And of course, if you're visiting Spitsbergen in the summer or Antarctica down in the southern summer, then the skies typically are too light to be able to see them. But on a number of our other tours in the Arctic regions, which I'll come on to, you can see Northern Lights, and indeed they're part of the sort of focus, one of the foci of some of our tours to Iceland and Sweden and Norway. So just to start with, there's a lovely image there of the Northern Lights taken in North Iceland, one of my favourite shots, taken by Adam Cherrett on a previous tour. I just thought that's a nice sort of shot of what you might hope to see from a good display of Northern Lights. But because we're talking about the polar regions, I also thought I might mention some of the polar explorers and what their impressions have been of Northern Lights. Two explorers I will mention: Fridtjof Nansen, the Norwegian polymath, a real sort of phenomenal guy who was both an extraordinary explorer, first made the first traverse of Greenland. He also won the Nobel Peace Prize. He was a trained zoologist. He's a phenomenal fellow, and he is also quite an artist. And he made this woodcut on the right hand of the screen there, showing an image of Northern Lights, the sort of lovely arches that you get, the arcs that you get when you get an early display of Northern Lights. So Fridtjof Nansen there, showing how you might want to depict them pictorially. But Scott, our perhaps most prominent, famous Arctic explorer of them all, as well, certainly the most famous British polar explorer, also saw the Northern Lights many times during his travels, and was really quite taken with them. On one evening, on the 22nd of June, so this was the midwinter's day, almost after a midwinter's celebration, down in the southern hemisphere, down in the South Pole. So this is the Southern Lights we're talking about. He said, "It is impossible to witness the beautiful phenomenon without a sense of awe. And yet this sentiment is not inspired by its brilliance, but rather by its delicacy in light and colour, its transparency, and above all, its tremendous evanescence of form." He went on to say, this is in his diary, "One wonders why historians do not tell us of aurora worshippers. So easily could the phenomenon be considered a manifestation of God or a demon." So he put beautifully into words there his experience down there in the southern Arctic regions, southern Antarctic regions, I should say, of the aurora that he saw one evening. And I love these words, above all, its tremulous evanescence of form. So he really spoke beautifully about how they appear. So this is a shot here of the aurora as they might be seen over the Lofoten Islands in northern Norway. A lovely photograph showing us a rich star field behind, but those pearly green glows of aurora looking north there across this beautiful landscape of the Lofoten Islands. So what are the aurora? Why? How are they formed? Well, in order to explain that, I need to digress slightly into a bit of astronomy, my other interest, and to explain that the sun is a major factor or is the major factor in the aurora. It is the source of the energy, if you like, that powers the aurora. And this is the sun today. This is how it looked earlier today from one of the satellites that are up there monitoring it on a daily basis. And you can see that it's got quite a lot of spots on it today. We're building to a solar maximum in the coming years, and this shows itself in the form of sunspots, as we can see on this particular image. And the sun is a very, very active body. It's a very active magnetically, it's very active electrically, and it's the discharge, if you like, or the solar wind that emanates from the sun that actually gives rise to the aurora. This is a close-up of one of those sunspots, and these are highly magnetized regions of the sun. So these are regions in which the magnetic field lines of the sun are twisted and enter the photosphere of the sun, and that is what's as I say, drives or is a manifestation of the activity of the sun. And these two gentlemen here, Heinrich Schrober, a German astronomer, and Rudolf Wolf, a Swiss astronomer, really worked out the whole, or started to realize the fact that the solar activity is periodic in nature. So that solar activity, with all those sunspots, the numbers of sunspots go up and down almost like clockwork we say every 11 years, but it can vary slightly from sort of 9 to 13 years, something like that. We get maxima and minima of solar activity. Just occasionally in the deep past or in the historical times, there have been periods of almost no activity in the sun, hence that period of solar, the Maunder minimum in the 1650s, from 1650 to 1715, and later in the early 18th century. But generally speaking, solar activity goes up and down on a roughly 11-year cycle, and that's what, as I say again, generates things like the solar wind and helps produce the aurora. The sun itself is, as I say, is a highly magnetized body, and when it's at solar minimum, you can really see during an eclipse the magnetic field lines. This particular shot, taken by Colin White on the 2019 eclipse in Chile that we ran, shows the sun at solar minimum 2019, and it shows that the sun really is almost has that sign of almost like a bar magnet, the magnetic field lines emanating from the polar regions in much the same way that you'd have if you sprinkle iron filings over paper with a bar magnet underneath. So it's a simple bar magnet when it's at solar minimum. But the solar, as the course of the solar cycle runs, the magnetic field gets twisted up and sunspots start to appear. And this is a shot showing solar cycle that shows the sunspots on the left-hand side in visible light, and on the right-hand side how the sunspots appear in the magnetization of them. This is what we call a magnetogram, and you can tell how they're polarized magnetically by looking at the spectra of the sun in those specific regions. So over the course of this solar cycle, this is a long period satellite that's been SOHO. It's been up in space since back in 1996 there, imaging the sun right through the course of an entire solar cycle and more. And you can see there how it increased to great solar activity in 2001, 2002, then it dropped away again, and then built again during the sort of period 2011, 2012. That was a period when I started to get involved in going to the Arctic regions to look for aurora, because it's a prime time to go and see them. Activities dropped away again slightly, and now we're starting to build up again to another level. But those that activity and those sunspots help to generate solar flares and emissions from the sun. And you can see here the arcs of material that form great arcs from the sun, from the solar surface, and they follow the magnetic field lines of the sun. And when those break off, when those are flung into space, when so much energy is put into those arcs that they can't withstand rather they break, and they fling material out into space in the form of solar wind. That is when the material then, if it comes towards the Earth, might give rise to a dynamic aurora. So where are we now in the solar cycle? So we saw the diagram with all the ups and downs since the 1600s. This is much more up to date and shows how we are now building towards another peak. It looks like in sort of roundabouts 2025, 2026, it will reach a peak again, but we're already ahead of the prediction. The predicted path there of the solar activity is in red, and the little diamonds there show the actual values of solar activity, sunspot number, in reality how it's been. So we had a fairly quiet solar maximum back in 2012, 2013, but it's looking like it might build to a higher peak, hopefully this coming time. So the solar wind, we talked a lot about the sun there, and the solar activity during periods of high solar activity, and indeed all throughout the sun's life, it throws off material which is called the solar wind, and this flies across space in all directions, comes towards Earth around about 400 kilometers per second. It takes about 4 days on average, depending upon its speed, obviously, to reach the Earth, and then it is deflected by the Earth's magnetic field. We have a strong magnetic field, and that protects us from those incoming particles. These are charged particles, they're electrons, they're protons, they're helium nuclei, which would do us damage if we didn't have this protection of the magnetosphere of the Earth. But what happens is that some of that material actually gets funneled down into the polar regions, as you might just about be able to see the way those magnetic field lines come down into the polar regions of the Earth, and that is where then those particles come into the atmosphere. They enter the Earth's atmosphere and excite the atmosphere, the gases in our atmosphere, which then give off the radiation, the light, the green light, the red light that we see as the aurora. And you need to be in the right sort of place in order to see the aurora, and the best place is under what we term the auroral oval. This is for the northern lights, the northern polar lights. There's a similar auroral oval in the southern hemisphere, but the average area that's spanned by this auroral oval, where the particles come down, is shown here by this green band, cutting across places like Iceland, North Norway, northern Russia, southern Greenland, and northern Canada, and through into Alaska. And these are the prime areas. If you want to see the northern lights, these are the best places to see them, because this is where most of that radiation enters the Earth's atmosphere. If you're too far north, if you're up in Svalbard or Spitsbergen, the main island, then sometimes you're too far north to be able to see them. It is possible to be too far north. If you're there, you actually have to look south to see the northern lights, because normally speaking, that auroral oval is further south than you, and you have to look south. But of course, you can only see them during the times when it's dark, and not during the long summer months when it's light all the time. But as I say, this is a mean sort of area of the auroral oval. When you get an influx of particles coming from the sun, that auroral oval can push further south, and of course, just occasionally we get to see them in North Scotland or even further south in the UK. And historically, it has been known for the aurora to be seen as far south as the equator, but this is a once in a century type event, very, very rare indeed. The majority of the time, if you're underneath, you really need to travel to somewhere around about this auroral oval depicted on this chart to be able to see them. From space, you can see the green light there of the oxygen emission. It's the oxygen gas in our atmosphere that gives that green light, and this is from the ISS looking down on the Earth, and you can see the particles there coming in towards the Earth. From our perspective down on the Earth, how does the aurora show itself? Well, normally, first thing you tend to see of an evening, this is very variable, and what I'm going to describe now is a typical evening. Typically, you get a sort of a band of light across the northern sky from the northeast through to the northwest. Typically, in the early stages, it's quite quiescent. There's not much structure to it, but as the evening develops, you get multiple bands. So on this shot here, you can see there's two bands, another arc going further north and higher into the sky. And that then can start to develop some structure and rays which move along the arc. And the arcs then should typically, if you've got a decent display building, will split into several different arcs, and you start to get waves and kinks and curtain type effects in those arcs, and as I say, rays of light and dark moving along the length of the arc. So you get a real sort of interesting structure starting to develop in the northern part of the sky. If, however, it's a really sort of strong display and it goes right overhead, you're right underneath that auroral oval, then you get what the sort of the pinnacle of an auroral evening is, to get a corona, not the solar corona as I was talking about the sun, but an auroral corona, and that is where the particles are literally appear to be raining down onto your head. By perspective, you're looking up into it, and you're seeing this amazing display above your head with lights sort of channeling down. It's like being underneath this sort of waterfall of light, greens and magenta lights. So, how predictable are the northern lights? Now, this is a good question, because many people call me and say, well, I've tried to see the northern lights on several occasions. I've been to the Arctic. I've not seen them. What are the best things we can do to optimize our chances, and how can we predict if they're going to occur? Well, there are different ways in which we can increase our chances. Firstly, as I've said about the solar activity levels, they vary on a cyclical way. So if you go at a period when there's more solar activity, then you have a higher chance of getting to see aurora. Having said that, I've seen plenty of aurora during solar minimum periods as well. And basically, you can look also on a shorter term basis. You can look at things like, are there coronal holes in the sun? So the diagram on the right-hand side here shows the sun and areas of coronal holes. Now, these give rise to a stronger, faster solar wind, and they may well trigger an aurora several days after they open up. And you can also look on websites which give sort of diagrams like the one on the left, which is a simulation of what the auroral oval looks like at a given time. Now, I tend to look at a particular website called spaceweather.com, and I encourage anybody who's interested in aurora to look at this website. It actually covers many aspects of astronomy and atmospheric phenomena as well. But on this website, you can see all manner of descriptions of what is likely to occur over the coming days. You see images of the sun there over on the left. This was only today that I grabbed this off the screen, so there's pictures there of the occultation of Mars last night as well on the screen. But this particular website does give you lots of extra information. So, for instance, on the right-hand part of the screen, this is just what you see if you scroll down on the website. There's that image there from Soho showing the coronal holes, and that tells you when the matter is likely to emanate from that and impact upon the Earth. Also on that, you can click on a link which then takes you to a page which shows you what we have, the actual interplanetary magnetic field. Now, this is a bit of a complicated one, and I'm not going to go into any depth in this, but by looking at this, and this is data coming from a satellite which is 1.5 million kilometers from us, and therefore upstream of us in terms of its solar wind, you can look and see what the incoming solar wind is looking like an hour and a half ahead. So if you're out there and you're looking for the aurora, and suddenly you look at this chart, and for instance, a key thing on that is that yellow plot on the second bar down. It's the BZ. It's the component of the interplanetary magnetic field. If it goes to the south, if it goes south of that dotted line across the middle, then you stand a good chance an hour and a half later of getting higher aurora. There's a good explanation for that, but I won't go into any detail on that. But there are ways, basically, of optimizing your chances of seeing it to start with, but also when you're out and about and you're spending time outdoors, and it is important to spend plenty of time out looking for the aurora, if that's what your aim is, because it really is a case of they can appear over a short period of time, and you need to be outside and enjoying them when they happen, rather than putting your boots on or missing it completely because you don't know what's going on outside. Now, photographing the northern lights, everybody who goes to see them wants to photograph them, and increasingly people have been able to photograph them even with small sort of phones on their cameras. On the cameras on their phones these days, and it's surprising now what sort of results you can get from that. But really, if you want to take sort of high quality shots, there are some rules that you need to adopt. Firstly, you need to use a wide lens, because a good aurora is an all sky event. So you want to be able to capture as much of it as you can. You want to open the aperture of the lens as much as possible. We're talking now about digital SLRs, of course, where you can manually check and set all of these different parameters. So you want to open the aperture. You want to set a high ISO, so it's at its most sensitive, possibly higher than 1600 these days. Cameras can have much higher settings and still not have the sort of graininess that we might have been used to 5-10 years ago. You want to set a shutter speed of maybe 5 or 15, 10, 15, 20 seconds, something like that. But that depends very much on how the aurora looks at any given time. So if it's bright, then you can probably reduce that shutter speed to 5 or even maybe 2 seconds if it's a really bright aurora. Of course, they move, so you don't want to have it too long, but at the same time, you want to be able to capture that light as well. So it's important to have a long enough shutter speed. And you need to focus the camera manually now, because of the fact that very often, or if you try to use autofocus, you've got it set on autofocus, the camera will struggle to know what it's focusing on. So you need to sort of be able to set it to manual focus and lock it in at that, so that it's then in focus for the duration. And the last point there about removing UV or polarizing filters, well, I'm in two minds about that. Obviously, they cut out light. Certain polarizing filters I would remove because they cut out a lot of light. UV filters can be helpful if in protecting your camera. And of course, I've seen many a camera blow to one side in the wind or something like that in sort of Arctic conditions. So it's often a good thing to have a UV filter on there. So maybe keep that on, particularly if it's windy. And what I haven't put on there is you do need a tripod. Obviously, if you're having shutter speed of sort of 5 to 20 seconds, then you need to have your camera solidly mounted on a tripod for that. Like I say, these days, increasingly, your smartphones seem to be able to take images of aurora better than I would ever have imagined possible. I'm not saying you'll get professional standard shots, but you can certainly get record shots with the more modern sort of iPhones and the like. So you might hopefully be able to get a shot something like this. This is a lovely shot taken looking over the glacial lagoon, Jökulsárlón, in southern Iceland, with looking north and seeing that lovely arc of the aurora reflected in the lake. And whilst I always tend to say it's good to go and try and see the aurora during a period when the moon is new, because it gives a darker sky, the moon for photographers illuminates the foreground. So you can get lovely sort of images like this where the foreground's illuminated by moonlight and you're still getting the aurora there. But probably for visual experience, it's probably better to go to see the northern lights during, as I say, a new moon, so that the skies are that little bit darker. Quick point about what you would actually see. Typically, cameras are much more sensitive to color than our eyes. So basically, they will show really rich, saturated green colors and some reds and some magentas. Our eyes will only just about pick up some sort of fairly faint green color. Typically, it's more of a sort of minty green. And this was a shot a painting made by an artist called David Hardy, who joined me on a trip to Iceland quite a few years ago now, and he made a visual depiction of what he saw. And this was, he felt it showed nicely the sort of, he could show better by painting the sort of effect of the sort of rippling that you get and the landscape, as opposed to photographing it, which would tends to just sort of show the really rich green color and often doesn't show the very great detail. Now, which trips of Naturetrek can you see the Northern Lights on? There are several. These are just a few. Swedish Lapland, the 2 Iceland tours in February and March, and our Finnish trip at Easter are certainly ones where Northern Lights are a feature of what we aim to see. We look to see wildlife during the daytimes as well, but on each of these trips, Northern Lights are a definite possibility. Iceland in the autumn as well. In fact, I was in Iceland September last year and had quite a nice display of Northern Lights. So that's another good time to see them, another good place to see them. So those are the sort of times. Really, we're looking typically around the sort of equinox type periods. September, October, February, March typically are probably the optimum times to go and see northern lights. And of course, during those periods, you do have a bit of daylight as well. Even though you're sort of maybe north of the Arctic Circle, or close to the Arctic Circle, you still have a good amount of daylight to enjoy the nature and the landscapes, as well as the northern lights by night. So thank you very much for listening to me about the northern lights. That's actually a photograph that I took back in September last year of the northern lights in southern Iceland. Thank you very much.